And I want to take a look here at example 3, which is actually a really important example. Because what is often going to be the case with L'Hopital's rule, and it's always been the case every semester that I've taught this, since I was actually in grad school at U of I helping students through Calc 1, is that people often misapply L'Hopital's rule, or after applying it, make some sort of crucial mistake. So I want to take a look here at example 3, where I'm going to ask us to try to determine what is wrong, what is incorrect about each of the following calculations here. So I want you to go ahead really quickly and pause the video to see if you can try to identify something in the calculation of part A and part B that is incorrect. What's wrong? Why would it be wrong? And then, after you think you have some ideas, go ahead, unpause the video, and you'll see me talk about each of these individual errors. All right, so hopefully you were able to find something in each of these that it maybe seemed a bit fishy or not quite right. So again, one of the first things that I need to make sure that I recognize that if I want to use L'Hopital's rule, I have to have a form of 0 over 0 or infinity over an infinity. Pluses or minuses don't matter, right? I just need one or the other, or a mixture of the two. So if I was to take a look here, as x approaches pi, I see that the denominator of this fraction is moving towards 0, but the numerator of this fraction would be moving towards -1. Right? Cosine of pi would be -1. So I don't have an appropriate indeterminate form, and so this step right here is not okay. I can't just take the derivative of the top and the bottom. Not acceptable. So I can see here that we don't have an appropriate indeterminate form. And that's really important because one of the things that I see, again, every semester that I teach Calc 1 is that I see people coming to really difficult limits in the future and they just start taking derivatives and thinking, oh, I'm using L'Hopital's rule. But wait, L'Hopital's rule required that you had a fraction that you were taking the limit of and that you had a top going to 0 and a bottom going to 0, or a top going to n infinity and the bottom going to n infinity. Okay, well, let's take a look here then at part B. Now, is the same mistake made here? Let's see, if x is approaching 0, then notice my top and my bottom are going to 0. So that's totally fine. I can use L'Hopital's rule here. And then apparently we get down to this. All right, let's check the derivatives. 3x squared, 6x. Okay, my derivatives look good. And then I use L'Hopital's rule again, and I get to 6 over 2, which is 3. So what's wrong here? Well, it's actually the same exact problem. Notice here, my top in this part is going to 0, but what's the bottom going to? 2. So if that's the case, then actually all of this work here is absolutely wrong. I should have just ended up with no L'Hopital's rule at all, and I just get 0 over 2, or I get an answer of 0. So again, I can say that the second use of L'Hopital's rule is incorrect, right? Again, we do not have an appropriate indeterminate form. Do not have an appropriate indeterminate form. So this is a really important thing to kind of, keep our eyes open for. We want to make sure that we're actually understanding when L'Hopital's rule can be applied. It has to be on something that has a fraction that fits the form 0 over 0 or infinity over infinity. I could never use L'Hopital's rule on something that is not in a fraction form, and I can never use L'Hopital's rule if I don't have one of these special indeterminate forms.